Okay, totally fine if some of them are wrong. We're gonna go over them in a sec. It is, but it should squiggle some. So it should start at the bottom and then you have the right shape. Which one? Which one? B is absolute value. And then make sure for your linear, it is a line, but the parent function is up. So you want it to start at the bottom. Yes, that's perfect. All right, let's check your graph. So your linear graph, your equation is going to be y equals x. Now remember, for most lines, it's mx plus b, but for the parent function, you're kind of taking the extra numbers out. So most of you drew a straight line. Make sure that it should pass through the origin and it should have a positive slope through that diagonal. Okay, so if you need to fix your picture a little bit, that's fine. Okay, quadratic, can anyone tell me the shape? It is a U. Okay, also it should pass through the origin. Because remember that even though the U can be shifted up, down, left, right, for the parent function, it stays right at the center. Okay, the equation for that is going to be x squared. Cubic. Kind of hard to describe the shape on this one. I just call it a squiggle, okay? But really you have one arm that's reaching up and then one arm that's down. Okay, you do want your cubic function to start at the bottom and then go uphill, okay? Then your equation should be y equals x cubed. Okay? For the first three shapes, okay, those hopefully are the ones we're most familiar with. For the next row, absolute value, do we remember the shape? B, very good. And then remember that the equation or the symbol for absolute value is those little bars. So you're going to put y equals x like that. Okay. Now, all four of those equations have the same domain. And here's why. Looking at it left and right, they all go to the left forever, and they all go to the right forever. So what would my domain be for all four of those? All reals. Very good. So you're welcome to write it out if you want. Okay, but all four of those are all real numbers for the domain. Now remember, domain is side to side. Range is up and down. So which of those have a range that goes all the way up and all the way down? Which two? Linear and cubic. Very good. Okay. So your linear and your cubic both go left and right both ways, up and down both ways. Now for the V and the U, they both go up forever, but how low do they scoot? To 0. Very good. So your range, you want to do the lowest point, comma, the highest. The lowest point would be 0 and the highest point would be infinity. Okay. You're going to put a bracket on your 0 because the graph does touch the x-axis. Okay, but infinity, since it's a concept and you can't like get there, you're going to leave that one open. Okay, then same thing for absolute value, 0 to infinity here. Okay. All right, the next two are probably a little bit harder to remember. If you were in regular pre-cal, you covered these in December. So if you don't remember, don't feel bad about it. Okay, but exponential, is going to be the growth graph. And it's going to start really, really, really close to the x-axis. And then it's going to slowly grow faster and faster and faster. Now, you should notice that this is the first graph that does not hit the origin. Okay, in fact, not only does it not hit the origin, but on this side, it never hits 0 ever. Okay? Does anyone happen to remember what number it crosses at here? Since it can't hit at 0? It is 1. Very good. Okay, so this one, instead of going through 0, 0, it crosses 1 box above the origin. Okay? And we're going to put for your parent function here 2 to the x. Where the x is like up top as an exponent, that's what makes it exponential. All right, exponentials and logs are inverses of each other. And what that means is they actually have the same graph, but it's reflected. So if you'll give yourself a graph here, rather than getting closer and closer to the x-axis, you're going to start really close to the y-axis, and then you're going to push away faster and faster and faster. Okay? All right, then you should also remember that if these are inverses, their x and y partners are just backwards. So if this one passes through 0, 1, what does this one pass through? 1, 0, very good. Okay, but you'll notice it's the same graph, it's just kind of flipped across the diagonal. Okay, and then probably good news, or y'all would think it's maybe good news, that these aren't on the AP test a ton. They are on there. We're going to do stuff with them, but if you remember the other 4, that's good. Okay. Which of those 2 graphs has a domain of all real numbers? What that means is it goes all the way to the left, all the way to the right. Exponential. For the log, though, it doesn't go all the way to the left because it gets stopped at what number can it not touch here? 0. So for your domain, you're going to put 0 to infinity. And for the 0, you're going to use a parentheses. And the reason why is that technically you can't actually touch 0 on, let's say, the x-axis. Okay? So that is how come we're giving a parentheses instead of a bracket. Does anyone remember what it's called where you get closer and closer but you can't touch it? Starts with the A? Asymptote. Very good. Okay. For the range, which one of those is going to be all real numbers? Meaning it goes up forever and down forever. Logs. And then for exponential, remember I want to go lowest comma highest, but what's the lowest the exponential can go? 0, but can it touch it? No, so I'm going to give it a parentheses. So I'll go 0 comma infinity with a parentheses, meaning 0 is the lowest it goes, infinity is the highest, but technically I can't touch 0. Okay, and remember we said that's called an asymptote. All right, for the next little 3 questions, I'd like you to do your best to list the transformations. Here are the words that I'm looking for. Shifting left, right, up, down, okay, and then vertical stretch or compression. Okay, so see what you remember for those 3. So shifting left, right, up, down, and then vertical stretch or compression. Yeah. All right, what are we doing on these 3? That's okay. Well, you mean moving it up, yeah, and then what flips it up and down? What would flip it? The number in the front if it's on a negative. Good job. Okay. All right, I'm just gonna do 1 and 3 because it looks like most of y'all remembered this. 1/4 is gonna be a vertical compression. Okay, and the cutoff for a vertical compression is it has to be a number in the front smaller than 1. Okay, anything bigger than 1 would be a stretch. Okay, which way does the -4 in parentheses shift the graph? Okay, to the right 4, I'm going to just use an arrow. And then the +3 would be up. Very good. Now, real quick on the third one, I'm going to skip the second one because it looks like peeking that y'all remembered this. Okay, for the third one, is this a compression or a stretch? Well, it can't be both. So the number in the front is a 3. Is it a compression or a stretch? Stretch. What does the negative do? Flips it. So this would be reflected over the x-axis. That's what the negative does, but it is still a vertical stretch because 3 is bigger than 1. Okay? And then for the +1, that would shift it which way? To the left. Very good. Okay? So the negative is what reflects it down. Some of y'all I saw had put Roxa. That's fine. Reflect across x-axis. Okay? All right. And then go ahead and turn the page. All right. Next page. I want you to try the factoring section. Okay. If you happen to remember the names of each type, okay, bonus points in your heart. Okay, but it's fine if you don't remember the names. Okay, some ideas are GCF, perfect squares, and then in my class we called it an AC chart, but I think other classes might have called it a trinomial. Okay, also grouping. So see if you can do any of those from 4 through 9.
Students, please card in the direction. Teachers, if you would please release freshman volleyball at this time to go down to the gym. They should be blocked, but please release freshman volleyball down to the gym.
Yeah. What's the square root of 25? Plus or minus 5, right? So do you remember you have to do one of each? So you have an x minus 5 and then an x plus 5. You should have one of each. Good job. Oh yeah, I'm gonna put that title up there, but it's not there. But that is the right answer. Yeah. Okay, so perfect square, right? So what's the square?
Square root of x. So put it in x, and then put another x, because you're gonna have two of them. Okay, then what's the square of 25? Plus 5 with that one. Put it in parentheses all together, and then a line. So perfect squares, we break it up, and then it's plus 5. Good job, that's right. Remember the name of that one? Yes, wow.
Hey, I put the names up there if that can maybe help you remember how to do any of so. Okay, so what do they both have? An X. Then remember, you can take the X out of the parentheses, the red X, then open a parentheses. You're just gonna put what's left over once you pull the X out. So if it was an X squared, yep, perfect. Good job. Great job. And then for this one, can you break that down even more? It's a perfect square, so you can end up splitting that one a second time. Good job. What are you trying to do? No, wait, isn't that, it's your book? Whatever she's I don't need it. Why do you need it? It's already our four side. But why do you need it? No. The, oh, that, I don't know. I did. You don't need to. I don't. Are you in? Oh, well, maybe it's because they want you to get that indoors. No. All right, just to kind of keep us moving here. Number 4. Okay, is perfect squares. I can square root x squared and 25 both perfectly. What is the square root of x squared? Just an x. But remember, I'm going to have 2 parentheses and each one's going to have their own x. Then what's the square root of 25? Well, and it should technically be plus or minus 5. So you end up with 2 factors, x plus 5 and x minus 5. Okay, for the second one, it's called GCF because they have a common factor. What can I take out of both? X. Okay, remember the GCF is going to go in the front, which is an x. And then whatever's left over, I'm going to leave in the parentheses. So my x squared, if I take an x out, is just a regular x now. My 5x is now just a 5. Because I had taken the x that was in there and I had pulled it out. Okay? All right, for today, we are going to skip number 6. We're going to do it next time. We're not going to finish all this today. So skip 6 and go down to number 7. Okay, there are a lot of different methods to do this. I'm going to teach it the way that I taught it last year. But you're going to label your trinomial, A, B, C. And then at the top of the chart, you're going to put the air conditioning or AC, and you're gonna put B in the bottom for the basement. Okay, AC is referring to you multiplying the number in the A position with the number in the C position. Now, if there's not a number in the A position, what number goes there? 1. So I would do 1 times 6 is 6. And then my basement number is the number in the middle, which is a 7. Then I want to list all of the factors that will times to the AC number. So if I want to times to 6, I could do 1 times 6 or 2 times 3. And then out of those choices, I'm looking for the ones that add to that basement number. So 1 and 6 are going to add to 7. Then it'll be x plus 1 and x plus 6. Okay. Now, if my basement number in the middle had been 5, then I would have picked the 2 and the 3 and done an x plus 2 and an x plus 3. Okay. So let's run through number 8. Set up your AC chart. A times C is 1 times negative 28, which is negative 28. And then I want to list all the ways that I can times to get 28. So I could do 1 times 28. Will 2 multiply with anything to give me 28? 14. And then my last option would be 3 doesn't go, but 4 does. 4 times what? 7. Very good. Okay, then my basement number is my B in the middle. It's a 3. Okay, but there's one important thing you have to remember about your AC chart. If your AC is a positive, you're trying to add to get that bottom number. If your AC chart has a negative number at top, you're trying to subtract to get this. So which partners will minus to give me 3? 4 and 7. And then I want to put the minus on the side that will make the 3 come out how I want it to. So if my 3 in the middle needs to be a plus 3, do I want to put the minus on the 4 or the 7? 4. So then your answer would be x minus 4 and x plus 7. Okay. All right. We're going to skip the rest of this page and jump ahead to number 14. I want you to try anything that you can for 14, 15, 16, and 17. Okay, so work together. Ask me if you need a refresher. Okay, but we're doing 14 through 17. If you probably can't remember how to do all 4, but just do what you can. So 14 through 17. Yeah. You joined this year. Are you in first period? Yeah. Yeah, he wanted to try it. Are you in the breakers thing? Oh, so that was like 7. Yeah, that was said. Not. He was saying he wanted to do it. And I was like, oh God. That's 7 is too much. When does it be slow? Likewise. Not at 7 a.m.
Well, he just looks like
And then is this one all this accounted down? Or is that separate? I thought there was like a competition, they were like flying around, or like, they might eat TV. And
yeah, there is that.
is that great?
That's right.
What, how many years? Nice. Okay. I'm on the wellness.
You know, I feel like all we have in our house is like boys stuff, you know? I feel like once, like, she's here, I'll be more excited, but I'm still very nervous, because then too, like, reminds of our girl, I feel like we're like so close. But wait, I'm not gonna be, I'll be like so hard to get. We have talked about some, but we really like them because I really love. And my husband hates this. So I keep calling her pennies, try to like see if he comes around. He'll come around, he'll come around. If not, I'll just sign the paper when he's not. You put it up to the 3, yes. Remember, so if it's a square root, you remember how you like square both sides? So if it's a cubic root, you have to do like the little 3. And then how do you do a cubic? Remember, you times it by itself 3 instead of just twice. How are we doing? Okay, so what do we do with the -2? Let's start with that. How do you undo a -2? Okay, do +2 on both sides, and then -4 + 2. What do we have then? Good. So you have your cubic root. X + 1 = -2. How do you get rid of a square root? Okay, you use exponents, that's right. So a square root, you would square both sides. Then a cubic root, you're going to use both sides. So put a little 3 up front to cancel out. And then do you remember how to find it? You just times it by itself 3 times. So you'll do -2 times -2 and then times 1 more. Yes, good job. And then get rid of the +1 by doing what? You'll do -1. Very good. Those are both right. Okay, now for this one, you're gonna divide the 8 to get it out of the front. And then do you remember how to cancel out an E? You do an ln on that side. Very good. Then just minus your 1 across. That's exactly right. Good job. Get rid of the E. You're going to do an ln on both sides. Yes. So, like for a lot of ours tests, you'll either have it for the AP test, it's half. So they have like a section with, section without, section with, section without. But we're gonna talk about like if you put like let's say like on this one with the negative to the third, like that. So it's like you don't have a calculator, but you're not gonna like lose points for doing not doing that step. It's mixed. So the multiple choice is online. And then but this is a problem for another day. It's not for today, okay? That's 3. I think you take this 6%. How are we doing? That was right, that was right. And then do you know what the cubic root of negative times 1 is? But it has to times by itself 3 times. So it's 3 times 3. And then times 1 more 3. That would be -3. So yes. Yes. And we did also put a little in and you are that's great.
Instead of asking on that.
All right, we're gonna do 2 of these just to kind of push you along here. So we're gonna do number 15 and number 17. Okay, this one, most of y'all got -9 is correct. If you didn't get that, as I'm walking around, tell me and I'll come help you through it. Okay, number 15, you should have minus the 27 across, which means that x cubed, okay, gentlemen, ready? Okay, is -27, and then to get rid of a cube, you take a cubic root. So you're going to put a little radical with a 3 in the elbow to show that it's not a square root, it's a cubic root. Okay, and then your 3 power and your 3 root are going to cancel each other out to give you the x by itself. Okay, then on this side, the way that you find a cubic root, okay, assuming let's pretend you don't have a calculator, you can just type it into, is you need to look for a number that when you repeat it 3 times, it gives you what you started with. So the answer is going to be -3, but let's check it. What's -3 times 1 more -3? Times 1 more -3?
-27.
-27. Very good. Very good. All right, one more we're going to do together right now. It's number 17. What do you think you should get rid of first? For 17, it's going to be the 6. But it would have been the 2 on the previous question. Okay, so we're going to minus that 6 across. 10 take away 6 gives me 4. Okay, and then a third means divide by 3. I want to undo that. So what's the opposite of dividing by 3? Good. Okay, so the 3 and the third are going to cross out. We have ln x minus 5, and then 4 times 3 is 12. Okay, from here, my class, we covered this in December, so it's been a while. Okay, but how do I undo an ln? It's a special letter. E. Very good. Okay, E and ln are reciprocals that they eliminate each other. So when I E on the ln, these are gone. I just have the x minus 5, and then how do I get rid of the -5? Add it. Now, you could put e to the 12 in the calculator, but for a lot of the AP test, okay, it's about half and half, no calc, that you would leave it like this. You wouldn't need to know what the e to the 12 power is. You would just leave it like that and then put a +5 at the end. So we're going to put a +5 here and here. And that is sufficient as an answer, okay? You wouldn't need to find like what that is as a decimal. This would be perfectly fine. Okay, if you haven't already, finish 16, and then we're going to add 18 and 19 off the last page. Off the next page, sorry. So we're looking at 16 if you haven't finished, 18, 19. Give those a shot. Okay, not 20 or 21 now. Good job, Kendall. That was great. Katie's so sad that you're not as good. Did Terry tell you?
So in my case, but I don't.
What do you have? Very good. Oh,
That's what I'm saying.
so you'd be swapping instead. Yeah, I think they probably won't do that this schema, but they might do it.
I did not know that. I think we see stuff though. Well, it's like I was at the period is not really. And also it's like, if I don't get a 5 on the exam, then I'm gonna wanna retake all of us.
Yeah. I hear it, I hear it. How we doing?
Is this complete?
Okay, so go back one step. So you had 8 e to the x equals 4. That was right so far. We gotta get rid of the 8. So you're gonna have 8 ln x equals 4 divided by 8. It would be a half, very good. Or you could even for the AP test, what we were talking about, you could leave it for grading, and they're not gonna take off.
Well, no.
But 1/2 is better if you do that.
You could only like probably.
So the ln x equals 1/2. Yes, yeah, right. So then, yeah, you do so put an ln on that side, and the answer is ln of a half. And you wouldn't have to know what that is. Well, you have an x is equal to, and then ln.
You put the right.
Here, it would be like this. So it'd be x equals ln of a half. Oh, you can't see it. Hold on. Like that.
Oh.
We did. We're only gonna do 2 more after this and then go.
Yeah.
Good. Okay, this is right, so then minus the 4 and by the -3, then how do you get rid of those square roots? Yeah, square, so you do -3 squared would be -3. Right? Negative. Because you're doing the negative times another negative, right? All right, we are gonna do these 2. And then just one more for today, and then we're gonna take a break. So hang in there, take a look at number 18. Okay, number 18, you should have started by doing what as your first step? Add the 4. All right, then 5 plus 4 gives me 9. How do I get rid of a square root? Square, and 9 squared is 81. Okay, now remember, a squared and a square root cancel each other out. Okay, so that's why we applied the 2 power to get rid of the 2 root, right? Okay, then add the 1 across. What's my final answer? 82. Very good. Okay. One more like that. What do we need to get rid of first? Plus 4 with a minus 4. And 1 minus 4 gives me what? -3. Okay, then from here, to get rid of this square root, you're going to apply a squared. And when you square, especially if this number starts off as a negative, you're really supposed to put parentheses around it. Okay, so I'm not just squaring the negative, I'm squaring the 3 and the negative together. Okay, that's going to give me x minus 2. And then negative 3 times negative 3 is 9. Add the 2 across. And it would be 11. Very good. Okay, now, quick question. Okay, if I take the 11, everybody listen to this because this is something you might have forgotten from Algebra 2. Okay, if I take this number and I plug it back in, I should end up with a 1. So let's just check our work real quick. Okay, if I put an 11 where the x is, okay, gentlemen. Okay, so we're going to check our work here that we're going to do 11 minus 2. We're going to square root it and add 4. That should equal 1. So I'm just taking my answer, plugging it back in. What is 11 minus 2? 9. What's the square root of 9? What's 3 plus 4? 7. What do you call it if when you plug that answer back in, it gives you something that's not really equal? It starts with an E. So this ended up being 9 plus 4, which was 3 plus 4, which is a 7. It's okay. Cross out your 11. That's an extraneous. Did you all do that? Yes. Okay, now the good news is that extraneous solutions can pretty much only happen in square root functions. So if you wanted to go back and check this one, it works out fine. Okay, but when I went back and plugged this in, the 11 didn't actually give me the same number on both sides. Okay? All right, the last one we're going to do for today is 22. So turn the page, please. 22. Okay, I would like you to factor the top and the bottom of that. Okay, the top you're going to do an AC chart on. Okay, so go ahead and try to break that down for me. I'll give you a minute to give it a shot. So the top is an AC chart, which we reviewed back on, I think, a previous page. So just do the top for now. So put ABC.
Multiply the top and bottom.
Multiply the top, but if it's negative, they have to subtract. But yes. So add to the bottom number or subtract based on what the top is. Okay, now if you take the 2 out here, that's so easy. What should I say? Now that one's a perfect square, split that bottom into a perfect square. Good, good. Now what can we do on the bottom? Well, we're looking at factor. So remember your types. You know it's not an AC chart. It doesn't have it. So is it GCF or GCF? What can you take out from? Pull the 2 out. Sure. So you'll do 2 parentheses. Yes, x squared minus, what would the 2 be when you divide by 2? Now it's x squared minus 1, and then can you break that piece down one more time? This piece. Now that's a perfect square. What's the square root of 1?
So the bottom of that, you'll have a 2 in the front, then you'll have an X with a +1 and another X minus. Oh.
All right, for the top, you guys did a stellar job. Okay, it's an X plus 5 and an X minus 1. Okay, for the bottom, you're gonna have to break it down twice. The first thing you're gonna do is a GCF. What do they both have? What number? 2. So I would take the 2 out, and that would give me an X squared and then a minus 1. Because I'm taking the 2 out, then my 2 divided by 2 leaves a 1 there. Then how can I break this up after I GCF it? Very good. That's called perfect squares. So my 2's in the front, I have a +1 and a -1. Okay, when you were in pre-cal, we did like a whole unit on how to find vertical asymptotes and holes. How do you know the difference? Something about top and bottom. What were you gonna say? Yes, exactly. If you have the same thing top and bottom, it's gonna cancel out. And that's gonna create a hole in the graph. So I want you to label here, hole is from the ones that cancel out. Okay, but if you remember, the way that you identify where the hole in the graph is it's the opposite of what you crossed out. So if I'm crossing out an X minus 1, what's the opposite of -1? So it'd be at X equals +1. Okay? Now, any X's that are left over on the bottom create a vertical asymptote. And so I do have one X plus 1 left on the bottom. Where will the asymptote be at following that same logic? X equals -1. Okay. So I'm going to write, since I already put my answers here. Okay, I'm going to put them in the blanks as well. So the hole was at +1 and then also -1. Now, for the domain, you're listing all the X's that your graph can't touch. Your graph can't touch vertical asymptotes or holes. So what we're going to put for our domain is all real numbers, except X cannot equal 1 or -1. So you're basically saying the whole number line's fine as long as you don't touch these 2 spots, because one of them's a hole, one of them's a vertical asymptote. Make sense? All right, it is 4 o'clock. We have about 20 minutes. So if you want to just talk, take a little break, you don't have any homework to work on tonight, we'll finish this next time. Yes. Yeah, let me write you a pass though.